So hi from my side. I'm Tilmann from the University of Konstanz, and well, first of all, of course, thank you very much for having me here. And what I want to talk about today is joint work together with Sasha Kevelo, who we also heard in the previous talk here. And well, as the title reads, we want to identify financial and real uncertainty shocks. And for this, we come up with a new identification strategy that very well fits this particular empirical problem. And well, as the title kind of gives away, we go for a proxy VR approach. And the main idea is to combine this very intuitive identification via proxies or instruments with the very agnostic statistical identification of non-Gaussian shocks using independence criteria. And I kind of want to walk you through how this works and why we go for this with this empirical application to the uncertainty shocks that we have at hand. And we go for this application because we think that it very nicely deals with the identification challenges you face when you want to identify uncertainty shocks. So first of all, in the uncertainty shock case, you have the good old reverse causality issue. So uncertainty affects the economy, and vice versa. Economic fluctuations could also have an effect on uncertainty. So you need to find a way to deal with this reverse causality, and that's why we go for this proxy VR approach. And in the end, we will use a proxy that is purely based on exogenous variation and uncertainty, and we just estimate the effects of these exogenous variations and uncertainty on the economy. So we deal with this reverse causality issue through the proxy that we are using. However, we are interested in estimating two shocks, and when we want to estimate two shocks, we need multiple proxies, and just the information from the proxies is not sufficient to get us the identification of the shocks, but we need some form of additional restrictions in order to do so. And well, in the case of uncertainty shocks, it's not that easy to come by with these additional restrictions because a priori it's not quite clear what or how uncertainty affects the economy. So theory predicts ambiguous effects, and that's especially also true when you talk about different types of uncertainties. So a priori, it's not clear what are the difference between these two shocks, or which shock might have a more pronounced effect on the economy. So it's hard to come by with classical restrictions on like impulse responses or forecast error variances. And that's why we go for this purely statistical approach to disentangle the shocks. And this goes hand in hand with the next point that I have here on the slide, which is that in previous studies, these uncertainty shocks have been found to be non-Gaussian. And we kind of make use of this non-Gaussianity in our identification as we assume non-Gaussianity, as we assume independence between our two uncertainty shocks that we identify. And that's enough, or this additional structure is enough to get us identification done. And at the same time, we also kind of deal with this non-Gaussianity because this independence assumption ensures that we get these nicely interpretable shocks with this nice ceteris paribus interpretation that we are used to. So in a nutshell, we use the proxy VR to separate our uncertainty shocks from the remaining shocks of the system, and then we disentangle our two uncertainty shocks that we are interested in with the use of this non-Gaussianity and independence criteria. And well, there is one last challenge that we face. So in our mind, we only have one really convincing proxy for these uncertainty shocks, which is the one by Michele Piffer and its co-author. And in the end, we use the estimated general uncertainty shock of their work as a proxy and want to kind of split it up or disentangle it into the financial portion of the uncertainty shock and the real market portion of the uncertainty shock. So we want to identify two shocks with just a single instrument. And so we need to find a way in order to be able to do so. And that is that's the part where these synthetic proxies will come into play. And yeah, I'll get into the details in a minute. And well, in the end, we will have these different types of uncertainty shocks, which fits very well into the literature that was kind of sparked by this paper by Sidney Ludwigson and her co-authors. However, before I come to this empirical application, let me introduce the econometric framework for our identification. So we start with the classical structural BER model, where we have the impact matrix B, which is the key element of interest in the structural BERs, and these epsilon t's will be our structural shocks. And then we are using a proxy in order to identify these structural shocks in the impact matrix. And of course, the proxy needs to fulfill certain conditions in order to be valid. And it has to be relevant. So it has to be related to the structural shocks of interest, which are these epsilon 1 tildes. And it has to be exogenous. So it has to be unrelated to the remaining shocks of the system, which are these epsilon 2 tildes. However, we want to identify two shocks, as I mentioned, so we need not only the single proxy here, but we need additional proxies, and we will generate these additional proxies from our baseline proxy. And well, basically, the synthetic proxies that we use will just be the baseline proxy squared or to the power of 3. And the backbone of this strategy is the assumption which I put here at the top of the slide. And so on top of the typical assumption that the structural shocks or the remaining shocks of the system and the proxy variables are uncorrelated, we assume that the remaining structural shocks of the system are mean independent from the proxy, which means that the proxy does not contain any information about the mean of the structural shocks which are not related to it. And well, of course, that's a more strict assumption. However, these proxies are typically constructed in a way such that they contain no information about the remaining shocks of the system at all. And so we would argue that this more strict assumption is very well in the spirit of how we think about the proxy variables and how they're used in practice. So we don't think we make an overly strict assumption. And well, we need this more strict assumption in order for the same conditions to also be fulfilled for our synthetic proxies. So naturally, also the synthetic proxies need to be relevant and exogenous proxy variables. And given this mean independence assumption, we make sure that this exogeneity assumption here holds. So if this mean independence assumption between the remaining structural shocks and proxy holds, they will be exogenous, or the synthetic proxy will be exogenous. And well, the relevancy, we have a small illustration which highlights that the relevancy is kind of tied to the underlying non-Gaussianity of the target shocks. So suppose you have this linear relationship between the proxy and the target shocks of our that we're interested in. And well, such a linear relationship is kind of the staple in the Bayesian proxy BER world. And if we have this linear relationship, then you can rather easily show that the relevancy condition for the proxy set to the power of 2 holds if the underlying target shock is non-Gaussian. And in our application, we have this rather strong prior that our target shocks, the uncertainty shocks, are non-Gaussian. So we are quite comfortable or quite convinced that this relevancy condition holds in our particular application. So these are the synthetic proxies. And now for the identification, due to the time constraint, I want to skip most of the technicalities and show you the moment conditions that we will employ to estimate our impact matrix. So in the end, we will go for a GMM estimator, and we will have the proxy conditions paired with the synthetic proxy. We will have the standard variance covariance conditions of the structural VRs. And then additionally, we have co-skewness and co-kurtosis conditions, which ensure that the two uncertainty shocks that we identify are independent. And here we just assume independence between the two uncertainty shocks, so we don't have to impose independence to or also among the remaining structural shocks of the system. So the fusion with the proxy VR kind of alleviates some of the independent structure that we have to impose in the shock. And in our case, that's quite nice because this, for instance, allows that these uncertainty shocks that we get might affect higher moments of the remaining shocks of the system, which allow flexibly for this interpretation that uncertainty shocks are higher moment shocks in the system. Well, so we will put these moment conditions into the GMM estimator, and we have proof and also Monte Carlo study to show that given our assumption, this is well successful, the identification works, and the assumptions are, to reiterate, we have independent and non-Gaussian target shocks. Well, at least one of the shocks has to be non-Gaussian, and of course we need to have the valid proxies. And well, I want to spend the remaining minutes rather to talk about the empirical application. And well, as we have an empirical application with a proxy, we first have to kind of assess a little bit whether the proxy actually serves its purpose in our application. And as I said, the proxy in our case is the general uncertainty shock from the paper by Michele Piffer and its co-author. And firstly, we kind of have to assess that this general uncertainty shock actually has some predictive ability for both a financial market and also a real market uncertainty shock. And for this, we check here the correlations of our proxy and also the synthetic versions with different uncertainty indicators. So with the VXO, an indicator for financial uncertainty, the stock market volatility, and the EPU, the economic policy uncertainty index, which is more an indicator for real market uncertainty. And well, we see that we get positive correlations of our proxies with these types of indicators for uncertainty, and thus we would conclude that indeed our proxy has predictive ability for these two types of shocks that we have. And well, in terms of strength, these F statistics here at the bottom, they refer to the weak instrument test by Kurt Lansford. And basically they show us that we don't have to worry that much about weak instrument bias in our application. And well, based on this, we conclude that we have a proxy that is valid for our purpose, and we put it into our identification machinery, run this GMM estimation, and then we get an impact matrix, we get shocks. However, a priori, we didn't impose any structure, so we don't know which shock is which shock. And we have to do this statistical identification, typical ex post labeling. And for the labeling, we basically entirely want to rely on the shock series themselves. The nice thing with these uncertainty shocks is we have historical events for which we can say quite confidently that we have an uncertainty shock at that point in the time. And you see the proxy that we're using at the bottom. You see spikes at different points in time where different events took place. And now ideally, these spikes sort into the two estimated shocks based on the type of events that occur. And we argue that's exactly what happens. So in the top row here, the shock that we label financial uncertainty shock, we see the stock market crashes in the late 80s. We see the hedge fund default, the bursting of the dot-com bubble, and 9/11 around the millennium. And then, of course, we have the largest spike during the financial crisis in 2008, a spike during the euro crisis, and the last spike here above 2 standard deviations is most likely the credit ranking downgrade of the US government. And then on the other hand, in the middle row here, we have different types of events. We have spikes before and at the start of the Gulf and the Iraq war. We have a spike around the government shutdown in 1996. We have a spike at the Hurricane Katrina, where a large part of the oil drilling capacity of the US were destroyed in the Gulf of Mexico. And again, we have the largest spike during the financial crisis. And the last one here is the debt ceiling crisis, where the United States government almost went illiquid. So we have this sorting of the events into these two different shocks, which made it for us rather easy to label them. And now the remaining 2 or 3 minutes, I want to show you some impulse responses. So on the left side, these are the responses for the financial uncertainty shock. On the right side, for the real uncertainty shock. And these dashed lines are 90% heteroscedasticity robust confidence bands. And here, the first set of impulse responses, nothing unexpected to see here. So uncertainty shocks increase uncertainty, and that's true for stock market volatility and also this economic policy uncertainty. Also, no big surprises when we look at more financial market variables. And by the way, these responses marked with the plus, these are cumulative responses of difference variables. And also here, there are no big surprises. We see that financial and also real uncertainty lead to a decline in stock market returns, lead to declines in the federal funds rate, and lead to an increase in credit spreads. And a nice feature here is that we see, or is hinted that the financial uncertainty shock leads to a more pronounced increase in credit spreads than the real uncertainty shock. And this relation between these two responses, for instance, has been used in the past as an identification restriction for these types of shocks. So it's nice that our agnostic procedure or agnostic strategy also is successful to replicate this economically intuitive result. And maybe the biggest surprise or unexpected thing that also we saw is that we only see this negative response of real activity here measured by industrial production for the real uncertainty shock, while there's barely something going on for the financial uncertainty. And one potential explanation for this is that we see here a negative labor market response for the real uncertainty, which we don't see for the financial uncertainty. So this could maybe highlight the importance of this labor market channel for the transmission of uncertainty shocks. However, on the previous slide, we have also seen that credit spreads increase, and of course, also credit spreads could play a role. And lastly, we have these ambiguous effects on prices, which is kind of consistent with the literature. So again, that's nothing that is really surprising to us. And I think I run low on time, so I will skip the forecast variance decompositions and just very quickly, once again, we have this fusion of the proxy VR with this non-Gaussianity, which fits very well to this particular application. And we see that our conclusion is that real uncertainty seems to affect real activity more compared to financial uncertainty. And that's maybe the main point to take away. And I think I'll stop here and maybe leave room for one quick question if we have time.
Okay, thank you. Does anyone have a question?
Yeah, then all right. Thanks
Okay.
again. And I'll
Thanks.
stop sharing.